Image display includes all of the system components necessary to convert the digital data created. From the reconstruction process to electrical signals needed by the city display monitor. The image display system includes the ability to display patient information and scan protocol data. The image display system includes the ability to display patient information and scan protocol data. The image display system includes the ability to display patient information and scan protocol data. An output device allows the information stored in computer memory to be displayed. The device used to display city images is generally a black and white or color monitor. The display device is either a cathode ray tube or some form of flat panel such as a CRT tube or some form of flat panel such as LCD. The most advanced is LED. A display device, cathode ray tube, regular conventional monitor, silo, a gritter into modern monitors are all LCD or LED. Because the monitor used in city works with analog signal, it is necessary to convert the digital signal from the computer memory back to an analog format. Because the monitor used in city works with analog signal, it is necessary to convert the digital signal from the computer memory back to an analog format. Now comes the camera. These are not the cameras that we are used. The camera is an output device that transfers the image from the monitor to the film. The camera is used to send the image to the film. The camera used may be a multi-format camera, although most city systems today include a laser camera. The multi-format camera transfers the image displayed on the monitor to film. The multi-format camera transfers the image displayed on the monitor to film. The camera is used to connect the camera to the film. When we select a printer, we have to select a camera. You have to select a camera or printer to print the films. Laser cameras bypass the image on the display monitor and transfer data directly from the computer, bypassing the video system entirely, thereby significantly improving image quality. The film used in City consists of a single image system. The film used in City consists of a single image system. The film used in City consists of a single image system. The film used in City consists of a single image system. The film used in City consists of a single image system. The technology used in the film is light emission spectrum and laser beam light. The film used in the film is light emission spectrum and laser beam light. The window is important in a City screen. The way an image is viewed on the computer monitor can be adjusted by changing the window width and window levels. The way an image is viewed on the computer monitor can be adjusted by changing the window width and window levels. A slice of the thorax shows the lung parenchyma. A slice of the thorax shows the lung parenchyma. The window setting is also important. 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 The windows are used for other anatomical parts such as abdomen, brain, limbs. This window is used to understand the lower SKR. It's also used to understand the lower SER and it's also used to understand the lower SCR endoscopic states for the reason why we use the window. Now we have to understand the gray scale. Gray scale is the shade of gray. Hounsfield unit, 2000 different Hounsfield values. And the monitor can display only 256 shades of gray. Our computer monitor can focus on 256 shades of gray. Gray shades means the scale from black to white. The scale from black to white is the gray scale. The values of this scale are shown through the Hounsfield unit. The number of Hounsfield units assigned to each level of gray. is determined by the window width. So, the number of Hounsfield units is shown through the window. The Hounsfield unit is the water density of the water. The density is 0. So, the Hounsfield unit of the leaves is minus 1000. The Hounsfield unit of the bone is plus 1000. So, the gray scale is from minus 1000 to plus 1000. Is the scale of the Hounsfield unit. The mass is 0. So, the Hounsfield unit is minus and the density is plus. So, the Hounsfield unit of the leaves is minus 1000. The mass is 0. The density of the mass is plus 1000. The window width determines the number of Hounsfield units given the specific image. So, in a picture, the window width is the range of the Hounsfield unit. The window width is the range of the Hounsfield unit. So, the window width expressed the range of the Hounsfield units. So, we can increase the window width or decrease it. The window width will be the range of the gray scale. We can increase it. The window level selects the center city value of the window width. So, the window width we are using. The center value of the window width is level. The window level and window center are often used interchangeably. The window level selects which Hounsfield numbers are displayed on the image. The window width assigns the quantity of pixel values to the gray scale. The window level determines the center pixel value in the gray scale. So, there are two types of window width. The full window width is the range of the Hounsfield units, and the center point of the window level is the window level. The particular Hounsfield units to be included in our image are entirely dependent on the window level selected. So, if we select the window level, which window will be in the image? If 0 is chosen as the window level, or if we make 0 as the center point, then the Hounsfield values that are represented as the shade of gray on this image will range from minus 150 to 150. So, if we select the window width from 0 to 150, then the window width will be 150 to 150 plus 150.